So as we begin our new topic today, I just want to bring out some basics very, very quickly. When we talk about functions, basically the main idea is this idea of inputs and outputs. So, if I have something like this, and I say to you, this is an input, and often we refer to the inputs as the x's, and I ask you, what is the y, or what is the output? If I feed 3 into this machine or this rule, what is the y that comes out the other side? Who can tell me? Yeah, this is going to be 5, because I go 2 times 3 minus 1. What if I put minus 3 in the side? What comes out the other side? So 2 times minus 3 is minus 6. Minus 1 is minus 7. Okay, that's cool. What if I put 0 in the side? What will come out that side? So 2 times 0 is nothing. Minus 1 is minus 1. Okay, so this relationship, or this rule, is a straight line relationship. And often the way we describe it is, instead of putting it in the spider diagram form, we talk about the inputs and outputs being x's and y's, and we describe them in this form: y equals mx plus c if they're a straight line relationship, or if it's a different type of relationship, the rule might look a bit different. Now, I think most of you will know that already, but what's important to remember also is this relationship has lots of mini relationships called coordinate pairs. And so some of the coordinate pairs that I've just shown you that exist in this relationship are 3, 5, 0, minus 1, and minus 3, minus 7. So those are just 3 little mini relationships that can come from the big relationship. And the place where we normally visualize relationships, or we call them graphs, is on the Cartesian plane. And so if we imagine the Cartesian plane, we talk about the x's and the y's, or the x-intercept and the y-intercept. This particular relationship, 3, 5, probably goes about, so like here, 0, minus 1 would be over here, and minus 3, minus 7 would probably be, I guess, down here somewhere, or maybe like down there. So let me just, and so this relationship is called a straight line relationship because the points, or the mini relationships that go together, make a straight line. And if you wanted to see where they're sitting, I'm saying that this point is 3, 5, this point is 0, minus 1, and this point is minus 3, minus 7. And often when we draw these graphs, we also we put the rule or the formula, we label them. Now, these are just 3 random points on this line. I want you to give me another point, or in this relationship, or another point on the line is another way of saying it. I've given you 3. Give me a 4th point that's on the line. You can put your hand up and I'll take suggestions if somebody wants to give a suggestion, or I want to see if you know how to use this rule. Okay, Fatejo has said 5, 8. Now, let me see if I can get 5, 8 as a rule. So 2 times 5 minus 1, I get 9. And so for Fatejo, I would say you're close, but my point would have been 5, 9. Because if I put 5 here, or if I put 5 into my machine, out pops a 9. Another student has said 2, 2, but be careful here, because if I put a 2 in, 2 times 2 is 4, 4 minus 1 is 3. So another point on the line would be the point 2, 3. Okay, 4, 7, I agree with. 4, 7 could be another point on the line. Okay, fantastic. So what I wanted to show you is that if a point is on the line, it has to obey this rule. And that's what I was going through there. And there's probably lots of points that could go there. Now, there's two particularly important points that are in straight line graphs and functions. The one is here, it's called the y-intercept. And the other one over here, this is called the x-intercept. Can you find me the x-intercept for this particular relationship? Masana, I'm just doing a little warm-up with straight lines. So I'm just doing a little, hang in there. You'll see now we're going to do questions and stuff, but I just want to do a little warm-up. Okay, a couple of you are confused. Hang in there. I will, maybe someone can come onto screen and tell us, how do you find the x-intercept normally based on previous things that we've done? Okay, to find the x-intercept, you need to make y equal to 0. All right. So if you make y is equal to 0 in this original equation, can you find me this intercept over here? This x-intercept over here. So we get 0 is equal to 2x minus 1. If I bring the 1 across, I get 2x. If I divide both sides by 2, I get that this coordinate over here is going to be a half 0. And that coordinate, or this mini relationship, is called the x-intercept. This one over here is called the y-intercept. And these are two important points when we talk about straight line graphs. I just want to do a quick check. Thumbs up if you followed what I've done so far. Thumbs down if you're feeling a bit uncertain and a bit unsure with this part. Okay, it's a mixture. Okay. This was just meant to be a warm-up or a little bit of a different look at straight lines. Okay. If you're feeling a bit unsure, the only thing I was trying to do here was show you how a straight line is made up of inputs and outputs. Those inputs and outputs are just called coordinate pairs together. And when we talk about these coordinate pairs, they can be put on a Cartesian plane, and together they give us a straight line. And there's a couple of important points on the straight line that we need to know about. Particularly important are the x-intercepts and the y-intercepts. And that's all we need to know for now. Okay, but let's get better at this. Let's do a bit of practice. So for my first question here, I want to give you an example, and then you're going to do what I do in the second example. So this is how the question goes. It says, for the line given here, find the gradient. Okay, so to find the gradient between A and B, all I'm going to do is use this formula. And so that would be 7 minus 1 over 4 minus 2, which is going to be 6 over 2, which is 3. Now, if you find the gradient between 2 points, it helps you find the equation of a straight line. So the equation of a straight line is always in the form y equals mx plus c, but you just found the m being the 3. Now, to figure out what the c value is, I need to use a point on the line. Which of these 2 points do you think is simpler? Which one would you choose? Put it in the chat there. Yeah, I think A is simpler. So I would write down the point 2, 1, and I would take that point and I would sub it into this red equation here. So I put a 1 where there's a y, and I put an x, a 2 where there's an x. What is my c value going to be from this equation? in order to get C, I need to move this to the other side. And I should get -5. So the equation of this straight line is 3x minus 5. Oh, have I done something wrong? Oh, 3x minus, have I really? 2x times 2, I put 1 there, plus c minus 5. It doesn't look like it. Let's make sure I haven't made a silly mistake. The gradient is positive, that's fine. 2, 1, put a 2 there, I put a 1 there. Okay, yeah, that's fine. Okay, then the last step. If I want to find the x-intercept and the y-intercept, to find the y-intercept, we make x 0. So what is the y-intercept going to be here? If I make x 0, how did I bring the 6 to the other side? It was +6, it becomes -6, yeah. So if I make x 0, I should get y is -5, or x is 0, y is -5. Now that drawing for some reason doesn't add up, but yeah. And then for the x-intercept, what do I need to do? For the x-intercept, I make y equal to 0. And for x, I'm going to get 5/3. So my y-intercept appears to be -5. My x-intercept appears to be 5/3. And that is the first example process. Now, there is something a bit dodgy about the drawing, but the method that I've showed you is fine. What I want you to do is I want you to try and do the same thing for me on the second example, right? So I've given you, let me just zoom out for a second. I've given you the working out to find the first one, okay? What I want you to do is I want you to try and find these three things: the gradient, the equation of the line, and the x and y intercepts for the second one. And while you're doing that, I'm going to take questions. What questions were there? Let's go and have a look. Can we ask Temba to unmute?
Afternoon, sir.
Hi, Temba. What can I do for you?
Sir, isn't the answer for C going to be 5 and not -5?
So if you put, can you see the point 2, 1? Are you okay with 3 times 2 being 6?
Yes, sir.
And then when I say 1, if I bring the 6 across, do you agree the 6 becomes negative?
I did it the other way around, sir.
Okay, how would you do that? So you put, because I think this point is wrong. So there's a mistake in the question, but if you go by what the question has got, it's got 2, 1. And so this is x and this is y. So that's why the x has to go here and the y has to go here. But I know what you mean, because if you look at the drawing, it feels like the y-intercept should be positive. But I think this is a mistake in the question.
Yes, sir. I took my 1 and I took it to the other side, and I took my C to the other side, which when my 1 goes to the other side, it becomes a negative.
Okay, but can you, okay, let's just do this. Are you okay with the 2 here going here?
Yes, sir.
Okay, are you okay with the 1 here going there?
Yes, sir.
So then, at that point, what did you do with the C?
Wait, sir.
Because I think what I would have done is I would have brought that 6 across, and that's why it becomes negative. But I think there is a mistake in the question, so I understand why it's confusing.
You know what I did, sir?
Yeah.
You see that it is 3 times 2, right?
Yeah.
And then when I take the C to the other side and I take my 1, I bring
But
it to
don't
the
leave
other
the
side.
C. Leave the C there. Leave the C where it is. Does that make sense? You would leave the C where it is. Okay. That's my top tip for you.
Okay. So
Let me go to Nitibokeng. Can we unmute? I'll try and unmute Nitibokeng. And then the rest of us are busy working on next one.
Hello, sir.
Hey, how can I help?
Sir, I understand when you say like when you're finding the y-intercept, you let y equals 0, and when you're finding the when you're finding the when you're finding the y-intercept, you let x equals 0, and when you're finding the x-intercept, you let y equals 0. But I don't understand like what you mean when you say like y-intercept, like intercept. What does the word intercept mean?
Okay. So if we look at this question, the reason it's called intercept is it's where two things meet. So look at the y-axis and the line, they intercept each other. It's almost like, you know, when you catch a ball between two people and you intercept, you get between them. So that's kind of what it's talking about. Like you intercept the one, intercepts the other. So this is called the y-intercept, and this is called the x-intercept.
Oh, okay. Okay, thank you, sir.
Pleasure. So what is my C value going to be? So if I put the ones in, I should get C is 7, and I get Y is minus 6x plus 7. And what are my X and Y intercepts going to be? X intercepts. The y-intercept is quite easy because when x is 0, it knocks out everything there. And so you can kind of see the y-intercept is 0.7. The x-intercept is a little bit harder. Like you have to do a bit of work to get there. But let's see, minus 7. Okay. So we should be getting our y-intercept is going to be 0.7. So this thing over here is 0.7. And the x-intercept over here is going to be 7/6, 0. Okay, so what have I been trying to show you so far? First of all, a function or a straight line function is made up of little points, and those points make up the straight line. That straight line has some important ideas. The one is the gradient, and then the intercepts are another important thing. And when you find the intercepts, the x and y intercepts, this approach will work for all types of other graphs like parabolas, hyperbolas, exponential, etc. Okay, so that was a little recap of straight line graphs. And what I want to do now is I want to practice drawing some straight line graphs. So what you're going to do for me is I'm going to give you the equation of two straight line graphs. And in order to draw them, you are going to find me the x and y intercepts. So x intercept of this graph, the y intercept. And you're also going to find me the x intercept and the y intercept of this one. And I want you to plot them on the same Cartesian plane. So over to you. I want you to take these two graphs, find the x and y intercept for each of them, and then draw them on a Cartesian plane. Linda, exactly. There's a lot of stuff from analytical geometry that comes into functions. Yes. In fact, we piggyback. The straight line stuff is exactly the same. Yes. we focus on straight lines at the beginning, and then we build to other functions like parabolas, hyperbolas, and all these. Tebogo, it depends on what your teacher says. Like, if the exam paper says label with full coordinates, do it. But it's also acceptable to write it. If it doesn't say that, it is acceptable to write, like I'm guessing you're saying, what if I want to write just a 4 there? That is acceptable as long as it's close by. But if the question says write full coordinates, use full coordinates. Okay, I want to give you some time to do that. So I think we can see that the y-intercept is going to be 0, 4 on the first one. And the x-intercept is going to be 4, 0. So those are the intercepts for my first graph. So sometimes the question asks for full coordinates, but if it hasn't asked for full coordinates, you can also just write like that. If they say full coordinates, then you would have to write 0, 4, 4, 4, 0. I'm going to, for now, for the sake of time, I'm going to just write the actual. Now, what about the second one? What's that going to be? Well, fortunately, its y-intercept is quite straightforward. The x-intercept takes a bit more work. So you can use your calculator here if you want to divide by 3/2, or you can times both sides by 2/3. That will also do the trick. So if you times both sides by 2/3, that cancels, and then you should get minus 8/3 for x. And so the x-intercept would be that. So what do we have? We've got a 4. And then a minus 8/3, which is probably going to be like around here somewhere. And this function. And that is that. Okay. So before we take our break, I want to know in functions and straight lines and all these types of worlds, this is called the y-intercept. But what's the special name of a point where 2 lines meet and those or 2 graphs meet? Can anybody tell me what that word is? Maybe pop your hand up and let me hear your lovely voice, or pop it in the chat. Cody, Simpiwe, you are on the money. That magic point where 2 lines meet is called the intersection point. And we're going to be talking a little bit more about intersection points in the second half of the lesson. Let me go to a question from McKen. McKen, how can I help? Can you hear me?
How can we get the 8/3?
Aha, the 8/3. Okay. So are you okay, McKen, with the 0 rocking up over here in place of the y? Are you okay with that substitution? So whenever you find the intercept, you make y 0.
So meaning we substitute the point.
Yeah. Well, no, actually just the x-intercept, you always make y 0. And that's why I've gone here where y is and I've put a 0.
Yes.
Okay, now, are you okay with this bit?
Yes.
Now, the only thing that's getting in the way and making my life difficult is this 3/2. And all I did was, if you divide, you can either times both sides by 2/3, or you could divide both sides and just use your calculator. And then that's where you'll get your minus 8/3 from.
Or meaning we can also reciprocate.
Yeah. Both ways you'll get minus. Some people do call Linda, some people call it the equilibrium point, yes. But in mathematics, the equilibrium point is more like a economics or physics terminology. So in maths, we normally call it intersection, but it's not wrong to call it equilibrium. It's just you'll more commonly see it in exam papers as intersection points. Okay. So why is the x-intercept of the equation y equals minus x plus 4 a positive 4 instead of negative 4? Aha. It's a good question. The reason is when the minus x comes to the other side, it becomes positive. And so that's why the x-intercept has to be a positive 4. That's a good question. Okay, everyone, we've been doing lots of maths for half an hour. It's time for a power break. So what we're going to do is we're going to stand up and we're going to be human. So let's take a moment for ourselves to just stretch. And
please turn on your cameras, guys. Let's see your lovely faces.
the
Give
power's
your mind a
back.
break.
Look at that. I'm so grateful I have the power. Okay, so what I want you to do is I want you to do whatever relaxes you. So I swing around and you know, you can do that, or you can do whatever relaxes you, but let's just start by just doing something which kind of loosens your muscles. And then maybe you can roll your shoulders a little bit. So stand up, make sure your head's not pointing down, look up. Just roll your shoulders a little bit. Maybe roll them forward. Then you can swing your arms in small circles to start with, but then make them slightly bigger. And then you can change direction, small circles, and slightly bigger. And then you can also do this from side to side. So the whole idea is you're just unwinding a little bit and you're moving your body. Let's do a tricep stretch. Do that. And then switch arms. That feels good. Oh, don't know why I think I've just got a tight left shoulder. And then just shake it all out. Shake out your legs. You can't see my legs, but just I'm shaking them out. Shake out your arms. And take a deep breath. Take one more. Okay, let's just raise your heart rate. So we're going to do jumping jacks, and we're just going to do 15. So in 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. And hopefully the blood is moving around your body and you are feeling like a human being again. And even though it might feel silly, I promise your brain works in a different way. It doesn't mind silliness. Sometimes it even enjoys it. So I hope that that was restorative. Okay, let's do some Math 24. Here are the Math 24 challenges. The easiest one is red, the hardest one is yellow. The goal is to make 24 using just the 4 numbers. And only the 4 numbers for each card. Okay, so Andile, this is 6. These are 6s. So that's a 6 and that's a 6. So they're both 6s. So you have to use those ones. We don't have to do the yellow one. It's just at this time. But the red and the blue is what I would. Okay, iPhone. I said 6 minus 2 times 6 times 1, which I think is indeed 24. And Simpiwe has said 2 times 6 plus 6 times 1, which is also 24. Okay. Cass has got 3 times 5. Oh, have you got the hard one, Cass? 3 times 5 plus 3 times 3. So that's 15 and that's 9. Oh, that's 24. Well done. And has anybody got... Okay, so there we go. Level has got the first one. 6 times 2. Okay, the only one that I can see that the group hasn't got is the blue one yet. 6, 2, 2, 3. Caitlin has said 6 minus 2, which is times 2 times 3, which is 4 times 6, which is 24. I do believe you are correct. And Lomex has said 6 plus 6. So Lomex, you would get up to 18, I think, at the moment. But if you added the 1 plus or 1 plus 2 together and you put it in a bracket, then it would work. Simpiwe has said 2 times 3 is 6. 6 plus 6 is 12. 12 times 2 is 24. Well done, everyone. Okay. Don't worry for Tekel. We just keep practicing and you will get better at this. And even if you're not, it's just a bit of fun mental maths to kind of get us out of the headspace we are when we're doing all this stuff. Okay, next question. Now, what I want to do next is I want us to draw basically draw graphs of this these two straight line graphs. And these are still straight line graphs. They're just, this is in non-standard form. So it's a straight line, but it's in non-standard form because it's not written y equals something. And this is what we call, the second one is f of x notation. And it means the same as y equals 2x minus 5. To draw them, you're going to have to do the same thing. Find the x-intercept, find the y-intercept. So I want you to draw me these two graphs on the same Cartesian plane. And I want them to be, I want you to draw them by finding the x and y intercepts. So over to you guys. Let's go. So for those who you don't have to change this into standard form. You can if you want, but you don't have to change this into standard form. Your method will still work, regardless of whether you change it or not. So for those who did, you'll see we get the same answer. Yeah, so you get the y-intercept is 0.4, the x-intercept is 2, 0. Now, what about this function f here? So 0.4. And then and those who changed this into standard form, that's completely fine. So some of you will have done this, where you went 4x or minus 4x plus 8, and then divided both sides by 2, and you got minus 2x plus 4. And that's just put it into standard form, but it's still the same. It's still the same graph. And what about this one? Well, the y-intercept is 0 minus 5. What's the x-intercept going to be? What would that look like if you drew it on your graph? Yes, Lomex, I agree. 5 over 2, 0. I haven't labeled these points, so I suppose I should do that. This is going to be the point 2, and this is going to be the point 4. Now, this is going to be 5 over 2, or 2.5. So it's going to be, what was the y? The y was down here. And I'll label that minus 5. And I'll label this 5 over 2, or 2.5. And what's nice is that if they've used the function notation f, we can just call this graph f. And so that is, that's probably worth a good 4 marks. Is it not supposed to be 4, 8? Which one are you referring to, Masana? So if you want to get, because you have 2y on this side, when the 2 comes to the other side, it divides both of these numbers by 2. So minus 4 divided by 2 is that. 8 divided by 2 is 4. So I get that one, and then, yeah, pleasure. Now, I want to point something else out to you. Can you see that the intersection point is over here? Now, it's quite hard to tell what the intersection point's coordinates are here. We were told to put them on the same axis. Which one are you referring to? So, okay, I'll follow up on that a bit later. But basically, one of the things, doesn't matter if we write 5 over 2 in decimals, it's completely fine. You can write 5/2 as 2.5 or 2.5. And if the question says write with full coordinates, then instead of writing a 4 there, you would have to write 0, 4. But I'm just leaving that out today because of the clutter factor. So whenever we are given only the equation and no coordinates, do we use the x and y intercepts when asked to draw a graph? Yes, Linda. I think the quickest way to draw a graph is to get 2 points if you're given a straight line, and the easiest ones to find will be the x and y intercepts. So that would be my recommendation, yes. All right. Now, we have a little bit of time left, and I think for the most part, you're okay with straight lines. So let's just do a little bit of extra vocabulary. And then we're going to talk about what Kamotso was talking about with the intersection of the graphs. And that will end today with those 2 bits. Before we move on, I just want to check if you understand what the notation over here means. So if I ask everyone, what is the f of 3? Can you tell me below what the f of 3 means using the language of functions and straight lines? Remember, f is like a character in the play. It's over here. What is the f of 3 going to be? So the f of 3 in function notation means the value of the function f when x is 3. It would just mean that, which is 1. It's function notation, yes. And so the f of 3 using the function f here is 1. If I asked you what is the f of 10 using the function I've got here, what would that be? Ongani, I agree. Ongani has said, put the x is 3 into the function f. So 2 times 10 minus 5 is 15. Yes, so we said f of 10 is 15. Now, because today is a lot about vocabulary, I want to test your vocabulary in other ways. So if I said to you, the g of x is minus 2x minus 3, and then I said to you, what is the g of minus 3? Could you tell me what that is using function notation? I've been a bit sneaky here. So minus 2 times minus 3 is going to be 6 minus 3, which is 3. And so the g of minus 3 is 3. Another way of thinking about this is that this is also telling me that the point minus 3, 3 is on the graph G. So this little relationship is sitting in the relationship G. It's one of the points on the line. Okay, so this is something that I want you to get better at too, is that when we use g of x and f of x notation, that we don't get scared of these symbols, that we know how to use them. And this is still a straight line because the x has a power of 1. Okay, last little bit for today is what happens if you have 2 straight lines and you want to find where they intersect algebraically. So I'm going to not find the point using visual, but rather using algebra. Now, I'll do a little sketch graph here. This has a positive gradient, and it probably looks something like that. This one over here is a negative gradient, and it goes through -5. So this one over here probably looks something like, okay, it's not perfect, but I want to find what that intersection point is. And one of the ways is doing an accurate graph, but another way of finding this is using algebra. And it's something that you need to be comfortable with for all types of functions. Now, at this intersection point, the y values of both graphs are the same, and the x values of both graphs are the same. And since at that point, both y's are the same, and this equation is written and y is by itself. If I want to find what that point is, I just make the two y's equal to each other, and I write that. If you solve this equation, you will find me the x coordinate of the intersection point. So go ahead and find me that x value, which is the x coordinate of the intersection point. What is the x going to be? So I think this is going to be okay. So I know, and the students in the chat are confirming this, that x is -2. How do I find the y value of that intersection point? What do I need to do? So Levo has said sub x into one of the functions, and I think the best thing to do is to sub it into the easiest function. And this one looks less easy than that one. That one looks a bit easier. So I'm going to sub it into this easy looking one. And I get -4 + 1, I get -3. And so my intersection point is going to be -2, -3. And the method we used was a simultaneous equation where we equated the two y values. Now, if this had been written where x was by itself, you could have equated the two x values. It wouldn't make a difference. Okay, so you have a go at this. I want you to find me the intersection points between these two straight line functions. Find me the intersection point between these two straight line functions. These are different ones. Off we go. What are we getting for that? What are we getting for the... I would start by doing this. And then I think I would do that. And so for me, the x coordinate of where these two intersect is x is 2. But I still need the y coordinates. Now, both of them look not that friendly, but I guess this one looks friendlier than that one. So to find the y value that it goes with, I'm going to go -2 - 1, which is -3. And I get 2 - 3 is my intersection point for these two graphs, these two straight lines. Now, the good news is finding intersection points even works the same if you have two different types of graphs. But that I'll do in a later. So isn't it x is -2? It's not, because when you bring the minus, it's because it changes size as it comes across. Okay, last one for today. I want you to try and find me the intersection point between these two straight lines. Now, this is a little bit trickier. Yes, Kamotso, like with a parabola and a hyperbola and those things. What do you think we should do? Maybe before I let you, somebody give us a hint. It looks like this is an easier looking equation. This is a more complicated. Is there something that you can do? I was thinking we can rewrite the easy equation in standard form. So what we'll call equation 1, we rewrite it in standard form, and we get that. And then we sub in wherever there is a y in the second harder looking equation, we put this value in here. And this is called substitution. So the last one we were using equating, whereas with substitution, we sub the easy one or equation 1 into equation 2. Find me the intersection point of these two straight lines. Because you see where what we are doing here is it's called solving it simultaneously. There's 3 methods that we use to solve simultaneous equations. The one is equating, the other one is substitution, which I've just done here. And then the other one, which we don't really use too much in this topic, is called elimination. But they all produce the same result. McKenna, what I would suggest is re-watch. Maybe I'm doing a little bit too much in one space, but re-watch this video and you'll see kind of what I'm doing, how I'm rewriting this, and then I'm subbing in here. So what do I got here? I've got minus 2x plus 16 is 21. And then this is x, and that is going to be 5. Now, what is the y coordinate that is going to go with the x is 5? Bongo PC, yes, there are other ways of doing this. You don't have to do it my way. I'm just kind of showing you one of the possible ways. Now, what I would do is I would sub it back into the easy equation because it already has y as the subject of the formula. And if I do that, I get y is minus 5 plus 8, which is 3. And so the intersection point of these two lines is going to be the point. Sonic, I agree, it's 5, 3. Okay, so what have we done today? We've done some basics of functions and inputs and outputs. We did the standard form of a straight line. We did how to draw straight line graphs. We did a little bit of function notation. And then at the end, we did how to find the intersection point of two straight lines. Now, for those students who are feeling a little bit overwhelmed, I suggest that you re-watch this video before our next lesson on Wednesday, and that will help you kind of get those basics in line. Okay. Level, can you put the link to the poll out for students now? And if there are other students who have questions, I'd love to answer them for you now. So you can ask your questions now, and I will do my best to assist. And the last one again, okay. So for Tekel, what I did was there's 2 equations. Of the 2, the easier one, I chose to make y the subject of the formula. And once I got that easy one, I rewrote my harder equation, and where there was a space for y, I left a space, and I put the other y value that I got from the easy one in there. Then I multiply out the 2, and when I do that, I get minus 2x and then plus 16. But then 3x minus 2x is just my x, and then the plus 16 on this side becomes minus 16 on this side, and I get the 5. Okay. Then once I get that 5 goes back into this equation here. Minus 5 plus 8 gives me my 3, which is here. Okay. All right. Are there any, so do we substitute any point to find x and y? You have to use the x value, McKen, that we just got. So because I found x was 5 here, I have to use that 5 to get the y value. You can't just use any point, no. Nakazimulo said, can you please repeat what an intersection point is? Oh, okay. An intersection point is a point where two lines meet. So, for example, let's say this graph looks like that. And I don't know what that graph looks like right now, but let's say it looks like that. Then this would be the intersection point. And the method I'm showing you now is how you find out what that point is. Okay. How did I get 16? The way I got 16 was I multiplied the 2 by 8, and I got 16. So is the turning point the same as the point of intersection? Sakila, it's not. The turning point is something that will come into parabolas later in the week. So if we draw a parabola, that is the turning point. The turning point is not the same. The intersection point of a parabola and a straight line, these 2 points would be the intersection point. Okay, so they're a little bit different. So what is this method called? So this method that we did where we substituted one equation into the other is called substitution. And then when we made the two sides equal, we call that method equating, which is this thing here. But basically, both methods help us to eliminate a variable. Okay, I think that's it for tonight. It was great being with you. Would this be the same if you were to use simultaneous equations? Yes, this is simultaneous equations. All of this is simultaneous equations. Can I use equating with the last example? You can, but for Tekel, the problem with equating with the last example is to make y the subject of the formula here is going to be clumsy. Like you're going to have to go like that, and then you have to divide both of these things by 2, and it just gets a bit messy. So it will work, but it just takes longer. That's why subbing in will be better. All right, that is it for today.